Welcome to another episode video on my robotic arm with pneumatic hand, robotic wrist and a controller with the compressor for the pneumatic hand. And the controller is connected to a computer with everything programmed in Python. Last time I ended with a little problem with this little black switch, in the sense that it touches, but all it did was this instead of all other switches which are present as well. Apart from that, also this doesn't work very nicely, and this is the motor for the yaw movement of the hand, which is once again the focus of this episode. The problem is that although this seems all to work nicely, if you leave this alone, because this is not very good yet. This is rope, and which is not very strong, but it's a start. A point is that this winch has a big problem. It slips over the axis, and I got a hint, and that is to replace this winch by a very different one. And that winch is this one. Now this is a very different construction. If I take it apart, well, you see this is a plastic axle, very different from this metal axle, but it's more or less the same one as used for this, and it can fit very nicely in here, with the advantage that this winch can't slip over this axis. So if I then put this one right here and fix it, it can be a nice replacement for this one. But I will need a slightly longer axis, and I need to reconstruct this whole thing because of these two notches where I can fix this construction in, and with that the whole winch. Apart from that, there is another point. There is a very small hole in this winch to fix the wires in, and those wires need to be much smaller than this. This will not go nicely. So although this construction will be there, this wire will probably need to be replaced, although I can try to feed it in, but the wire that should go in is this. And this is exactly the same wire I'm using for the vertical gearbox. So those are just a few things that I have to check, including the software for this part. So what I want to start with is reconstructing this, so I can put this in it with a longer axle. And if I replace put this instead of the rope, I'll see then, although better be not, but anyway, let's start with thinking how to reconstruct it, because this is directly connected to the axle holding and I need to take it all apart. So let's go. So now I have made this construction, which should be placed right here, but it cannot be placed here right now since I have to do some preparations. First of all, this has to go, otherwise I can't take off this, and I have to replace these three small parts by this block, which is the same as this one. Otherwise this notch won't fit anywhere. So let's see how I can do this. First of all, carefully take away this. Take out this wire. Will this wire come back? I don't know yet. Then I need to take this off, replace this one by this, and like I said, this one will go right here. Oops, don't drop things. So this one will go right here, which should be an exact and nice fit. And this is a very tight fit. So I don't know if this will actually make it. A slightly longer axis coincides with this axle, so I don't know how this will end up. Then this wire needs to be freed and taken away. Taken away from this one as well. Then the point is now this one will have to go complete. Yeah. And this wire is complete. So this one goes this one goes, and now I have one solid complete wire. Will this actually fit in here? Well, with all these knots I'm not quite sure, but I can try at least one little part. If I can twist it tight enough that it fits into that hole, but right now if I twist it like this, even then when it's very tight, the end doesn't even fit in it. So I guess that's it for this part of rope. Idea was nice, but it simply won't work. That said, let's put some parts together. I'll start with this one. although it should be replaced by a simple block, but I'll do that a bit later. No, let's keep this like this. So this one goes here. Then this one I have here, and let's be careful. Oops. Dropping everything again. Not too professional, but I don't care right now. So this one goes here, and this one goes right there. And then it should more or less maybe fit. Somehow. Alright, so this I have to turn around, because this notch should fit in here. And then I find I have a problem with this one. So this bar will have to go for now. And then I find I have a bit of a problem with this construction. And this is never going to work, so I need a longer axis. Idea is nice, but not complete. Alright, let's try again. Okay, after some chaotic reconstruction, this could have been it. Basically, the guides are not yet installed, but I replaced this block and I put this in place, and I tried to fix this. But there's a catch. First of all, this one, guided by, let's see if I can make this visible. Yes. So the axle for the winch goes through this block, which is this kind, and this one is supposed to stick on it. However, the problem, and to get it in, I had to shift the motor backwards. However, this one can be just taken off. And yes, that is a big problem, because if I put in this longer axis, it is a direct crossing with this one. And this one is coming like this right here. So let me take this one. This one goes here, this axle goes through here, and with this longer axle, well, you see the point, they interfere. So I have a spatial problem, and I'm not yet sure how to solve it. Can it be solved? Well, it should be, but in this way, it has no grip on the axle. So when I put this forward and this motor back in place, and then you find all sorts of other problems. Alright, then you get this. But if I now switch on the motor, this axle, I can just turn around, and that should not be possible. So one solution brings another problem. Ouch. I did a little change. I made a little change, and the change is that I shifted the winch a bit that direction. So now this one here, this gear is a very tight fit, and it is maybe a bit too tight, but the only thing that will tell if it is too tight or not is actually running a short test and then see if it actually does work. So I have started the diagnostics interface and will run this motor, which is actually here on the interface extension motor 4, so it's actually on the slave 1 motor 4. Let's see if that actually works at all. Alright, this should be the right one. It is connected. I don't see anything happen, which is not nice. Am I using the right one? Yeah, no doubt I am using the right one. So, and yeah, the connection is a bit flaky at moments. Maybe this works. It's not working. No, because it's I select the wrong one. Now it works, and no, it slips. It totally slips. So this isn't turning, but this is neither. And that is not a good way. So how to improve this? Alright, maybe a bit tighter. Try again. It runs, but not oh, no, this is wrong, this is wrong. This is very wrong. Okay, stop. It actually ruins this part on one end. Way too tight, way too tight. Yeah. This is not good in any way. So well, not ruined, but it is just touching it. So how to do this? Because if I put it again right in here, so then with this being the minimal thickness of material, it is a too tight fit. So how to solve this? That is a very good question. If I could make this only half of the width, I would be helped. but I have no idea how to do that. So experiment failed as of this moment, or for now, but there has to be a solution. As kind of solution, I have now made this construction made out of thin connecting plates. It's not an ideal situation, but at least here with the gear it's a very thin plate, so this gear can run freely, and it holds also the axle to the from the motor, so there's no obstruction anymore. And when the motor runs like this, it just runs. So that is a nice construction, and the new thing is, or the rest should be in here and going there. And anyway, this works for now. And after construction ends, I still have to find out how the motor can be controlled from software, because last time the stop command or the zero speed only slowed down and didn't stop, and I don't like that happening. Anyway, this is one thing. So now I could put this in, provided that everything really will work. And here I already have another problem, because this doesn't go in tight enough. But if I lift this a little bit, it used to be a very tight fit in the old construction. Alright, not preferred. No, this is just a loose end, so I have to find a different solution for that. Okay. Alright, so then I will have to find out a way to put this cord in it, and with that I come with the problem of connecting it to this plate, because this has to go. This hook and the hook on the other end is not a way to nicely connect the cord. So more things to do, and first get it in somehow. So the problem is now how to deal with the motor. This is the raised pivot, raised yaw, which is the motor on top, and I programmed it as 0 and 3. Now the question is, does this work? Because last time this only slowed down the motor, and it didn't even pause for time sleep 2. So whatever the reason, it didn't work. I'll test it for now a bit. and then probably, most likely, it won't work either, but the only way to find that out is do it. So running. Yes, because I have the interface diagnostic still running. Close. Alright. So run. And the switch does run. But the yaw motor doesn't run at all. And yet it is connected. So the question is, why doesn't it run? Alright. The motor doesn't run at all. And I also don't see any indication that it comes here, and no indication of digital 11 being dealt with. It is here, you can see that 9 and 10, but no 11. Alright, run some more. And although 11 is being pressed continuously, well, not continuously, but every 1, 2, 3, 4, 5, 6 seconds, is not detected in any way. The motor is not doing anything. Why? Why isn't that motor doing anything? Another thing is that this is motor 7, which is running all the time. So if I go here and I disable motor 7, so I do it like this, save, and then what happens? Alright, let's do it again. Then the pivot motor doesn't run at all. So I will hold this the yaw switch, and now things start running. But in one way only. Alright, let's see whatever happens. And again only either very slowly, but not stopping. And this exactly the same way. So this isn't good. How to solve it? Well, finding out how a motor has to stop, and that will probably be something like this, 8 comma and stop, but I'll have to find it out. And for the last part of this video, I did change the algorithm a little bit. Turns out that just the letter S means stop, so I changed that, and let's find out if it actually works. Well, so far it doesn't do a thing, so I press this switch, which helped earlier. Now this stops, now this works. And alright, so this goes the long way, and now this should make it stop, and then this runs, but yes. Now see if it runs both ways. Unfortunately, it goes the same way. So I need to change the direction. Yes, I need to change the direction. So that's a mistake in the algorithm. But when this pauses, this runs, and when this runs, this pauses. So that's a nice one. The cord in here will have to wait till next time. The algorithm needs to be adapted a bit, but so far it's a nice result for today, for this episode. So thank you for watching. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment if you want, I appreciate it. If you you can also follow me on Twitter, retweet and like, leave a comment. Follow me on Instagram, like, give a comment. Please donate to keep videos coming to you. Very much appreciated. More information at the start of this video and on my website. You can also become a patron to and then I will mention your name either on just my website or in the video, depending on how much you pledge. See my website for more info, and this is going to be continued, obviously. For now, thanks again for watching. Bye bye.